Hello everyone, welcome to my class. In today's class, we will solve questions based on rational number, which is intended for lower secondary checkpoint, paper 0862. So, let's see. In the previous session, we have already discussed what are rational numbers, irrational numbers, and surds, how to differentiate between a rational number, irrational number, and identify a surd. Okay, so let's solve few questions based on that. Here are some numbers. Decide which of these is irrational. Okay, so here we need to identify which are irrational number. So as you know, all the whole numbers are rational numbers, right? So 126 is rational number. Then square root of 121. So this can be written as a whole number 11. So this is also a rational number. Now see, you have another number that is pi over 6. So we already know that pi is irrational number. So when pi is divided by that irrational number is divided by a rational number, you get the result as irrational number. So pi over 6 is irrational number. Now, cube root of 17. So look, what are the cube numbers? So 1 and then 8 and 27. So we don't have this 17 anywhere in between them, and we cannot find cube root of 17 as a whole number. So this is also irrational number. Now you have another number as 1.36 recurring. Okay, so see 1.36 recurring. This can be written as 363636 and so on. See, there is a pattern followed here. This is non-terminating, but a pattern is followed here. So this belongs to rational number. I hope this is clear to everyone. Now, you have another number as square root of 3 whole squared. So, when you whole square root of 3, you get root 3 into root 3, that gives you 3. And 3 is also a rational number. So, this is also a rational number. Now, let's see the another one. Here you have root 36. Root 36 is nothing but 6. So this is a rational number. And then we have root 48. Okay, let's see. Now, you see 1. What are your root numbers? 1 square root numbers. Square numbers 1, 4, 9, 16, 25, 36. 49. So square root of 48. This is not a square number. So we will not get any whole number answer for this. And this is your irrational number. Now root 64. Root 64 is nothing but 8. So this is a rational number. And root 84, again you see 7 7 is 49, and then 64 and 81, and then you get 100. So these are the square numbers, and we don't find root 84 here. So value of root 84 will not be a whole number, and this cannot be written as a rational number. So this is your irrational number. Now cube root of 100. We cannot find cube root of 100. This is also irrational number. Now let's see another question. In each of these numbers, rational or irrational, give a reason for each answer. Okay, so you have to identify the answer for these will be rational or irrational. So, see, you have root 3 plus 6. Now, we already know that root 3 is irrational and 6 is rational. So, when you add an irrational number with rational, the result is always irrational. So, this is irrational. Now, the next one is root 3 plus 6. So, what we can do is first we add the numbers. So, you get square root of 9. And we know that square root of 9 is nothing but 3. So this is a whole number and nothing but we can say this is a rational number. Now the next number is root 64 plus cube root of 6. Root 64 is 8 and cube root of 64 is 4. So you get 8 plus 4, 12. So again, this is a rational number. Now here we have cube root of 8 and cube root of 19. So we can write cube root of 8 as 2, but we cannot write this cube root of 19. So this is one irrational number, so our result will be irrational. Now let's go to the next question. So show that square root of 2.25 is a rational number. Okay, so this is a rational number if we get some whole number as the answer. So let's see how to work on this. This is 2.25. So square root of 2.25 can be written as 225 over 100. So this is nothing but square root of 225 upon square root of 100. And you know that square root of 225 is 15 and square root of 100 is 10. So you will get here 1.5. So this is a rational number. Okay. So 2.25 is equals 1.5. So therefore this is a rational number. So this is not a whole number, but this is terminating decimal we are getting. So this is a rational number. Now look at this question. Is square root of 25.25 a rational number? Give a reason for your answer. So let's see how to work on it. Square root of 20.25. So this can be written as 2025 over 100 in the fraction form, which is nothing but square root of 2025 over square root of 100. So this you know already, square root of 100 is 10. Now let's see what is square root of 2025. So you can always do prime factorization to find out that. So you can divide and then so this we can write directly 15 times 15. Yeah. So you get this is nothing but 45 times 45. Right. So we will write here 45. See. See, square root of 2025. We got the factors as 3 times 3 times 15 times 15. Okay, since we are looking for square root, so pair them up and you get here 3 times 15. So that is 45. So we can write this as 45 over 10, which is nothing but 4.5. Therefore, square root of 2025 is a rational number. I hope this is clear to everyone. Yeah. Now let's see how to work on the next part. Cube root of 1.331. So what is cube root of 1.331? This can be written as cube root of 1331 over 1000. Then I will split it 1331 over this is cube root and here also cube root of 1000. So cube root of 1000 we all know that is 10. So let's calculate this one. We will do prime factorization for 1331. So let's see what we get the answer. Okay, so we will start with 11. 11 ones 11, 2 is 22, and then okay. So we got here cube root of 1331 as 11. So 11 over 10 is nothing but 1.1. So we got the answer for cube root of 1.331 as 1.1. So this is also a rational number. Yeah, I hope this is clear to everyone. Let's go to next question. Yeah, this is one important kind of question. Without using a calculator, show that. So you know that your paper 1 is non-calculator paper. So without using a calculator, show that 3 is less than cube root of 41 and that is less than 4. Okay, so since this is about cube root, so what we will do, we will cube all the numbers here. See, we will do 3 cubed, cube root of 41 cubed, and this cubed. So 3 cubed is 27, and then when you cube this, you will get 41, and here you get 64. See, we can show that easily, that cube root of 41 is greater than 3 and cube root of 41 is less than 4. So this is proved here because see, 41 lies between 27 and 64. Hence proved. Now we will do this one. Again we do the same thing here since this is about cube root of 800. So this is cube root. So we will cube all the numbers here. So you can cube and then cube root of 800 is cubed and 10 is cubed. Now you get here 729, and when you cube this one you get 800, and 10 cube is 1000, and see, 800 is greater than 721 and less than 1000. So we have showed that cube root of 800 is greater than 9 and less than 10. Easy. Yes, another important question. So this question is, without using a calculator, estimate dollar, oh, not dollar, square root of 140 to the nearest integer. Okay, so let's do that. So 140. So this is about square root. Okay, we will do one thing. We will write all the square numbers. See, 1, 4, 3 squared is 9, and then okay, let's go to directly 100. 10 squared is 100, and the next square number is 121, and then next square number is 144. Okay, so see, this square number 144 is larger than 140. So you can see here 140, square root of 140, it falls between square root of 144 and square root of 121. So this comes between in these two. But your question is to estimate square root of 140 to the nearest integer. Okay, so see here 140 is very close to 144. See here the gap is of 19. 21, 121 plus 19 will give you 140, but 140 plus 4 will give you, here the gap is very less. So we will say that this square root of 144 is 12. So square root of 140 to the nearest integer, answer will be 12. So this is our estimate. So I hope you can estimate easily now. Now look at this one, B. cube root of 350. Okay, so we will write cube root of 350 here, and we will write rest of the cube numbers. Okay, so your cube numbers are 1, 8, 27, and this is 350, right? So we can go to the larger number. Okay, then you get 64, then you get 125. Okay, and then 6, 6, 36, and 6, 6, 36, 3, 6, 3, 18. So next 6 cubed is 216, and then 7 cubed is 7 cubed. 7 cubed can be written as 49 times 7 will give you 343. Okay, and then 8 cubed. 8 cubed will be was 32, 3, 8, 512. Okay, now you see that 350, cube root of 350, it lies between cube root of 343 and cube root of 512. Now you see where it is, which number it is closer. 350 is close to which number. So we can see very clearly the distance between 343 and 50 is just 7. But if you look here, 350 and 512, this is more than 150. Okay, so 350 is very close to 343. So what is cube root of 343? This is 7. So we will say that estimate for cube root of 350 to the nearest integer is 7. I hope this is clear to everyone how to estimate the nearest integer of a square root and cube root. Yes, this is one important question. Now, this is one another important question. Show bracket 5 minus square root 2 close bracket, and then another bracket 5 plus root 2 is rational. Okay, so literally we have to solve it to show that this is a rational number. And I hope you remember, you have studied in your learner's book a plus b and a minus b. This gives you a square minus b square. So we can follow this rule. See, a square. Let this be a, this be here a, here b. So we can write a square means 5 squared minus b squared means root 2 squared. So you get 5 squared is 25 and root 2 squared is 2. So you get the answer as 23. Okay, so by any chance you get confused in exam, or you think this is something like you find it difficult to remember, you can also solve it this way. 5 minus root 2 times 5 plus root 2. So we can multiply 5 times 5, that gives you 25. Then 5 times root 2 will give you 5 root 2, and minus root 2 times 5 will give you minus 5 root 2, and minus root 2 times root 2 will give you minus 2. See, here 5 root 2, 5 root 2 gets cancelled, and 25 minus 2 gives you 23. So we get same answer. But this is one important rule, because this is introduced to you for this kind of question. So you must follow this pattern to solve this question. So let's move to the next question. 7 root 12 over 2 root 3 is rational. So here we need to prove that 7 root 12 and 2 root 3 is a rational number. Okay, so what we can do is we can split it. Say 12. What are the factors of 12? 2 times 2 times 3. Okay, now 3 cannot be written as, we cannot split it more. So you can rewrite this as 2 times 3 over 2 square root of 3. And now you see here 7. This is 2 squared. So 1 will come out and you get like this, root 3 over 2 root 3. Yes. So what we can do is here 2 root 3 and 2 root 3 can be cancelled. So you get 7, and 7 is a rational number. So we showed that 7 square root 12 over 2 square root 3 is a rational number. Okay, so this is the last question of this topic. This Venn diagram shows all the numbers on a line. A is set of integers, B is the set of rational numbers. Copy the diagram and put each of these numbers in the correct place. So what it says that A is integers and then B is rational numbers. Okay, so A is integers. So what we can write here for A, you can select from here. So we can write this 5 and so 25 is integer, right? Yeah, 25 is integer, and then square root of 25 is nothing but 5, so you get 5 also as integer. So A is set of integers, so inside this A circle we will write 25 and square root of 25. Now this circle B, it represents rational number. Okay, so 5.5, this is nothing but 54, 5 over 10. So we can write here 5.5 and then 5 and 5 over 19. Okay, now you see that cube root of 25. Cube root of 25 we cannot find actually, and this doesn't fall in the category of rational numbers also, and we cannot write them in integers also. It means that cube root of 25 does not belong to group A or group B, so we will write it outside. So whenever you get a question of this kind and you feel that any number doesn't belong to this any of the categories, you must write that number out of the circle or box, whatever is provided, but you cannot leave it because that is the part. So you can write it here so that it doesn't belong to any of the group, but it belongs to the whole group like this. Yeah, I hope this is clear to everyone. So these questions were for paper 0862, which is for lower secondary checkpoint, and this is also useful for year 8 students. And see, if you have any questions you can put in the comment section. Let's see, and we will come with few more questions. Thanks for being here.